Okay, so with this next one, it's a little bit complicated. We've got a sine square root of x divided by x dx that we're integrating here. So let's think about some options in terms of choosing our u. If we had tried u equals the sine of the square root of x, well, what would that give us for a du? Well, we'd need to have the cosine of, now this is a chain rule, but we can stop right away because there is no cosine over here. So there's no way we're going to be able to get that du in there. So automatically, I don't think this is going to end up being a good choice. So let's try the term inside the trig function again. We'll try that square root of x. So if we let u equal the square root of x, which again is just x to the power of 1/2, then that would mean that our du is going to be, so we take the derivative general power rule, it's going to be 1/2 x to the power of negative 1/2 dx. All right, so that looks a little bit messy. So let's maybe take stock of what we've got right now. So we've got the integral of the sine. Now we've let this be u. And so here's a possibility. What if we put that as a u in the bottom? Well, now we've got a problem because we still have to get that dx out of there, and taking the integral of sine of u over u is also another problem all into itself, so we're not going to worry about that. So since we can't get our du in this form, I'm going to put that denominator back as the square root of x. So is there a way for us to take this du statement and get rid of the remaining traces of x that we have in this integral? Well, let's explore what this statement is. So we've got 1/2. Now x to the power of negative 1/2 is the same as 1 over the square root of x dx. And now we should start to see that this is going to end up being a promising result. Because if we were then to take this statement right here and multiply both sides by 2, we would have 2 du is equal to 1 over the square root of x dx. And if you still can't see it over here, remember that this is just the sine of u times 1 over the square root of x dx. And now we can replace this with a 2 du. So we've got the integral of sine of u times 2 du, which is just 2 times the integral of the sine of u du. Now what we do is we integrate, and we've got 2 times negative cosine of u plus c, and we just clean this up for a final version. So we can write this as negative 2 times the cosine. Our original u was the square root of x, and then we've got our plus c. So, getting the du dx situation resolved was a little bit messy in this case, but we got there. And sometimes you have to do that. You have to think about how can you express rational exponents as radicals or negative exponents as reciprocals, and we need to make those connections in order to see our problem through.